What are the difference between a workshop and a lecture? A lecture is mostly manual. We talk about which is a workshop. Interact. So, if there's anything you need to clarify, any questions you ask, and let's see how I can help you. It's your homework. Another big question is the balance from building a robot, building a robot. That's big. Okay, 10% of the audience building a robot with us. That is actually good to do. Right? And 25 there were so many people for very but very abstraction doing things. So just to give instructions on this team, senior engineer, engineer, electronic engineer, those are the projects that they achieved over there. I don't know what it is. So I was trying to put in this video, but how is it really going? So let me put out the video and show you how things work. This is actually a really reminder of things in the stuff. How life works. This is not even part of it. Okay? This is a basic life robot. Remember that your life following event, there are many more things that there will be circles, round shapes, T junctions. There will be a white line, black line or white background. There will be a white line or black background. There's going to be a ramp. That's so much more. But understand that when a video game, just observe how precise and how you are doing remember robots are working on instruction. So let's watch again and see how precise is it turn. They are very crisp. Right? The turns, the movement, the way it has the curves, right? The response time is very crisp and very fast. Look how fast it makes the turn. Right? I will talk about this as we go on in our right. Okay. So look again on how fast it takes the turn. It's not going out of the line, it will speed, the way it breaks. Right? It's all about control. Right? And how precise it stops. Just like breaking. Very little, no overshoot, right? No lagging, right on the dot. So how is this kind of precision possible? Let's see as we go on with the session. Okay. Right. So these are the tasks that we have. The last session covered things like what sensors you have to use, what modules you have to use, and the basics of how to follow that. I want to go a step further. I will tell you about how to tackle user section. I divide the tasks that you all have in your line following game, these are the sections. So basically, basic line following. That is line following, following that line, and while line. Then is wall following. Follow wall. Then in your line following, finally, the rank. No pair of rank. What task? Now, if you look at any line following, these are the steps that you have to follow. Now, for example, that's always listen that I cannot, I can't tell you everything when it comes to robot. This is, I'm going to tell you the secrets, the little things that will help you to build your robot. I'll be gaps. That will answer your question. But I'm going to teach you is the thinking pattern. But we as lecturers, as academics, what we're trying to teach you is not to spoon feed you everything. You all have done your modules in your campus, done in the Excel. You notice that they teach you principles, fundamentals. But how you apply it and how creative you apply it in your robot. Now, let me give you a very easy example. This is how your thinking pattern. Thinking pattern. I know these robots always run on precise instructions. That's the fundamental of a robot. And robots, just like us, have sensors, right? They can see, they can touch. So those are the sensors, the inputs. What is the output? That is the motion of the robot. Now, what you are trying to do is control the brain to analyze this input, input output. Now let's get to the line following robot. Now, if I am a line following robot, and this is my line, that is my line. How to that? First, I should have a mechanism to detect that I am on some line. Detect that I am on a line. If this is the line I am on, and if I start my journey from here, I will love it. So, point number one, I need to detect that I am on a line. Now, me being the robot. This is the first step. How I should detect the mass? Second step. Now, if you are on the line, how am I going to detect which part of the line? So, which part of the line are you on? Are you off center to the left? Are you off center to the right? How do you know that? You need some mechanism to know if you are off center. The third point is, okay, let's say you're fine off center. Now, what you need to do is the wheels. Then follow the line. And if I'm moving again this way and I'm going off, what should I do? Use some directions to come back to the center of the line. So this is the fundamental principle of any type of line following. You might find the most complicated robot of line following. For example, Amazon uses line following robots to move around their inventory in large warehouses. They use the same concept. So these are the concepts that we will take into account. How is the robot going to do it? How is the robot going to do it? And what is the robot going to do it? If I am moving on the line, if I go astray from the line, how am I going to? What is the next corrective option? If I am moving to the right side of the line, what should be my corrective option? Turn back to the left and correct it back. So this is my approach to this line following problem. So this is the thinking pattern you have to put in your head. How to go in this line following problem. Right. Now, as I said, we see, just like we see robots perceive the environment by looking at some sensors. So, ladies and gentlemen, these are the sensors that you need to have. These are called IR transmitter sensors. They will be very close to the light. Don't this. So this is where your line will be. Your line might be somewhere like that. So how are you going to manage between the line? So you need to have that placement. And if at all this area is white and this area is black, right? If at any point this sensor comes across something black, what does that mean? That you have gone way off. And if at any point, if this sensor has been perfectly on the edge, right? If at any point this sensor detects fully back, this sensor detects fully white, what does that mean? You're slightly offset. So you need to realize that this is the basics of line following. Okay? So you can have basically two sensors. You can start with two sensors. And when you want to go further, you can have 4 to 5 sensors. Some people go with one number of sensors, some people go with even number. I'll tell you what. If you have 4 sensors, you have 4 sensors. If you place these sensors in such a way that your line will be perfectly between these two, then you can, if this line comes, that line is related by any of the sensors, you know that you're going wrong. If you have a number between in the middle, right? And then this will be another between, if you can keep that different sensor on, you first ask me, if I need 2 sensors, why do you this? Okay, however, errors. And how are you going to get the inverted line? If the line is inverted, you are on a black background, the white line always. And sometimes people have more sensors, sometimes this sensor comes in and you're like, it's like a hammer star. There are many sensors over it, right? It has also. Again, people do this to recognize the different shapes on the sensor. That's right. Okay. So let's move on to that. So this right. So as I said, right, fundamentals of line following is to think that if you have 2 sensors, if the second is the middle more sensor, you have 2 sensors. One sensor is black like this, right? Okay. If both sensors are perfect by this body. So fundamentally, 2 sensors are enough to keep you on the line. But having more sensors on the side, you can take other shape according to your timeline, not the prediction. There are many shapes that we I understand shapes over here. So these are the shapes that we need to do. And how are you going to do it? Obviously, I can't give you algorithms to create each of these shapes. But remember, there are ways to create these shapes. Like I'll tell you some brief, right? If you have you have a sensor right? And if you come to a theta, So anyways, these sensors will detect that. But these sensors will also detect. So the only condition, right, for all four sensors to detect that is to have a station. Now, there is another case. Assume there is a case in the line, the whole arena, that now you are switching into black, black background with white. How are you doing it? How are you doing it? You fully invert. Now you have invert. Right? So one approach is you can have about few layers of sensors, right? Few layers of sensors that are thicker than this. So maybe you can have two lines here and then maybe another couple of sensors over here. So if all of the sensors are detecting black and suddenly these two sensors are detecting white while these two sensors are detecting black, there is a likely chance that you are on the inverted line. Like chance that you are on the inverted. But remember, after more incidents, there could be cases that you might not miss. There could be cases that you might not detect inverted line. And similarly, there is an so just like this, there is an inverted T on. You have the normal T on the white background. You have an inverted T, the black background, white color. So similarly, in case to detect this, you need to have the entire algorithm system. So you need to have two algorithms. You have one algorithm to detect inverted line, one algorithm to detect normal line. Another algorithm to handle the board. But for the RAM, you might not. Uh, I want to show you this because the cells are different. It's difficult to understand what is special. Let's say, how we going to handle this? If the sensor is like this, how much the sensor is moving like this towards this way? How we going to detect this? The right line. So, if you're moving this way, are detecting, like surrounding some okay? Yes, this and it is a Z shape. How are you going to move the rope? These are cases that are telling you that you need to think. It's not designed that. So the robot comes like this in a Z shape, right? Like like this work. So if the robot comes like this, right? And then how if you detect the Z, how you going to turn? Because remember, if you turn to left, the robot is going to go this way. So you need to make sure that you turn in such a way to align yourself perfectly. Just precision, right? Third, most likely we give that like this. If the sense that is like this, right? Boom, there is nothing here, and like this way you get the this works the same way. And start doing circles are circle, there would be a case like this. If the circle is like this, there is a line that enters the circle, and then there is a line that exits. Now, how are you going to handle this case? The robot is going to enter the circle this way. The robot is going to enter the circle this way. It's going to go. And sometimes I have seen on most competitions, the fellow goes again. And how are you going to do jump? And sometimes there are multiple techniques for this. If so, how are you going to know the track? I'll give you a small information. Have you ever used Google Maps in roundabout? Or use Google Maps and in your path, there is a roundabout. Do you remember how we say, take the first exit, take the second exit, take the third exit? Okay. So in a roundabout, you are driving around, right? There are different exits. Like normally for us, if there is a roundabout like this, and one path is one path. Okay? Like when we hear someone, we are coming in the car. Okay? But we hear someone, when we say someone, we will like, go straight. But for Google Maps, for him, this is the first exit. This is the second exit. This is the third exit. Right? So, similar algorithm, if you move up, this is the first exit. If there's another bar this way, it's the first exit. The second. In case the robot turns this way and goes to the exit to come back, you should take the next first exit. The first exit. To detect the next exit. But some people don't have a way to detect the first exit. Okay. And also remember, the robot can go clockwise. Yes. That is not something you need to think about. Robot wants to think of this way. It does this. You need to solve that distance. If it starts with this way, then it needs to look for exit. I find out there is exit this way. There's always exit outside. And sometimes I've seen at competition, people have not. In this case, you can always look for exit to this side. But sometimes I've seen the robot goes this way and it keeps looking for exit this way and keeps going in circles because it cannot find an exit inside. So it turns the opposite way that. So again, what I'm trying to tell you, I'll tell you everything, but I'm telling you how algorithms, algorithms for your to integrate your own. There is no right or wrong way to implement this, but I'm telling you algorithms. I think I should be getting you that as well. I'm telling you how to approach the world. I'm thinking. So whenever you get tasks like this, like the others, always assume but just the robot. If you were a robot, what does? Because we always try to work it can do this. But as a robot, we need to assume what does the robot see? How many sensors will capture each case? So each of these are cases. So if the robot comes here, then at this point, what are the sensors that will be triggered at that place? Each flow. Okay. Similarly, are there other cases that might trigger the same set of sensors? Are there other cases that might trigger the same set of sensors? Each flow. How can I include maybe another sensor to have a unique case for that? As I said, all will be triggered. Even from the white, even the light, the same degree will be happening. So how are you going to distinguish the two at the point of a robot? For the robot, what are the same? So how are you going to distinguish? That should be your thinking. For each of these cases, take a piece of paper. Take your other programming pen. Take all the cases. If you want, if you don't know, ChatGPT this and get the case. And plus each of these cases. Because if not, there might be cases the robot is doing well for all the obstacles, but for some of the people mess up. And that will ruin your entire program. And the best thing, the worst place actually is happening. So, constant and a speed time following So, I showed you some videos as well. In my keynote. And there, most of the robots were doing really well until the circle. So they have not thought about it. So these are things that we, right? So, going back, very, very, very. So, this such case, if the robot has more sense, this is how. So in case number one, you can see these two are out, while these two are within the. In the next case, you notice this what you are doing this case. It is the cover to wings. Actually, this happens. This is when the robot is here. Happens when the robot is now what do you do? Corrective action. The third condition, correct motive, where all the four sensors are on the right side. The imagine this side is not there. Imagine if this side is not there, then what would be the condition? This side was not there. Then this sensor will be activated, and this sensor will be activated. And what does that mean? We have a let me tell you something that you will think. What if there is something like this? The teacher, you're coming this way. There is a path over here, and there is a path. How can you distinguish an L is and a T? Okay. Now, okay, now, all then, now, you have is the how we will any plan is because that's only thing you can do, right? Only thing you can do for what I'm saying. What the thickness, the length of this. You come here, and you see this, okay, fine. But you still see white. Right? Part is on it. You see white. What does it mean? This there is, you know there's a path here, you have to make a distance. Even that you have to think. If there is a T junction, what is the distance? Is it left bias or straight bias? Or most of the time it is left. Most of the time, as a rule, go left. So where you why are we doing left bias? So let's say the robot comes. Robot left, This does not be created, comes back again. Right? At this point, it is turn left. In this point, this is left. So it will explore both paths. That's one reason can have better idea. Because if you always tell go straight, if the right, it might not do much work. Right? I'm always telling you these are some solutions I am telling you over the document. There is no correct way to do this. If your robot works, okay, so what I did is get your brains thinking to approach this problem not as a person who is holding the robot, but you have to be the robot and the robot how is this right? Moving on. So as I said, I was going to little concept, which is called which is called which has to be a word about it. For those of you who don't know, I have to quick feedback. The idea is right. We are very it is because of the robot that I showed in the video. Because it is not just concept the base, but dynamic based adaptation. Proportional means if I am walking towards this place, if I am robot walking towards I need to break my proportional means the closer I am to the place, the more intensive my brain. The closer I get to the rest, if I am at this my brain. As I go closer to the rest, my braking intensity, I go very close. So, something like this, coming to a that is, there are ways, right? If there is this thing, I'm going very far, I'm going off the line, that change has to be quickly. Now, you want to get over there's a whole lot of theories. Right? Integral, as it says, is the accumulated derivative. Now, I'm following this line. I'm slowly. I'm not doing that. So before this accumulation happens, there is a change that so at the end of the day, your correction, your real correction, according to some similar function like this. that gave me, they their constant. And is measured in biology. The thing they are substance that you what better you better. So fiber okay the constant fiber. So you want to get better performance, you need to tune this perfectly. How do you do parallel? And I have seen people in Sri Lanka who have done robotics, who have done robots, who have done KIK in tuning by using NATA. They run multiple. So basically, what we're looking at is tuning this and probably getting good values, proper values, right? So this is very important. And if you are trying to build a good robot, if it's your first robot, if you are trying to get a good outcome from your robot, wall following, what is the wall following? Right? Your system is going to have a wall that needs to be followed. Probably a corridor that needs to be followed. And how are you going to do it? You need to add some sensor. You use sensors like this, or any type of sensor that will maintain a constant distance. If you have that part, you have two walls, how are you going to do it? Especially in the side. See, if you are equal distance from either, you don't need the left wall, you don't need the right wall. How are you going to do that? You're going to do this. Basically, you're going to have two walls on either side, and you need to follow. And you can see that you can have basic, proportional, and PID control to that as well. So, what is basic? Basic control means the moment you get too close to one, you are increasing the you have only one, maybe zero. Now, as I am walking, I feel there is only 11 inches inside. Increase the now, if I just increase the speed quickly, I might go to 1 inside. Now, I am going too close to the other. So, what I do? Quickly, but this here, I increase this. Now, I am again, then this. I am going towards that. Now, as a result of this, I'm going to go on like this. It's but robot is going to do well. Why? Because you are making all and all change. You make a change proportionally to how often you do. If you are too centered to become purely one inch, then you make a little change. If you are 6 inches towards this side, you make a bigger change. You are almost making the work. Now that way, I might still go like this, but my bubble will break. But if I want very smooth button movement, then I can use B and B, where I can go smoothly to accumulated errors, perfect changes like that. Right? So this is how you can handle the ball covering function. Having sensors that would detect make sure you don't be edge. Correct. Correct. My take on this is, if the RAM is on a certain level, and if your robot can handle the RAM, don't make much of change. Because you don't need to do anything much with it. Because as long as the robot is following the line, you're fine. As long as the robot is following the line, you're fine. Then you go on the RAM, make sure that the robot doesn't slip. How do you know somewhere slip? You need to calculate the similarities. You know what the material of the wheels are. You know what might be the coefficient of the RAM. And if your wheels can handle the weight, you go up on a little. Don't overthink it and over engineer it. Basically, once you're done with the robot, consider that you have a RAM, build a RAM, build a small RAM, and the robot and see if it works. That's fine. But remember the things when you are building your robot, right? You know, my vehicles with bigger transformers, with more controls. So remember the distance that is. So if you are building a robot, right? Building a robot with wheels. If your wheel is like this, if you are having too much electronics like copper, and if your RAM starts like this, if you are having too much in front, your wheels over here, your RAM angle does not meet that requirement. So consider this. Like the body. So you need to this is the only concern, and also the wheel is the picture of the wheel. And after that, this same as line following. Your robot doesn't slip. This doesn't happen. Mention that within the I have mentioned that I will right. So basically make it stable. Consider the sensors, adjust the speed and maintain track. Again, speed adjustment we can do it from going very fast. And need to sensor to see if you're on the lap. If you're on the lap, that means your brain is going to maybe don't go in the same speed you're going. Maybe reduce the speed a bit. That's why your engine is stable. And other than that, if your robot doesn't hit the edge, if your graphics is maintaining your mind. This way to maintain friction your camera. There are different techniques. Some people use tape, some people use rubber bands around the wheels. These are different techniques used to make it. Right? Okay. Last technical slide I have is about the inverted line following segment. Right? It is how are you going to nothing to be afraid of. Right? In the inverted line following segment as well. Remember, how are you going to detect signal? As you did in all the other cases, how are you going to detect? That is the key part. Your algorithm should have three keys and four key sections. Normal line following, wall following, inward line following. So whenever the conditions that are required to satisfy each of these cases are met, you need to switch your code into either of these sections. Are you following the white line? Are you following the black line? Or are you not following anything but entering the wall following? So how do you measure wall following? You have walls. So from the start, you have to keep checking if there are walls. The moment there is noise, you forget the lights. The moment there is a white light detector, you forget everything. Okay, now you are a white light. The moment you detect a black light, you are on the black light. And the moment your IQ sensor detects change in the angle of the robot, angle of the vehicle, that means you are on the ramp. Right? You need to slow your speed down and slow your growth. So these are the conditions that you need to switch your entire algorithm from one to another. Either you're on the ramp, you're on the white line, the black line, or the. So there is saying these are small thinking patterns and algorithm fixes that you need to do in order to get your robot going. We started with the late, so I was going to go through some interesting parts at my keynote speech, and I'm going to share this with you again. You all are here, I'm happy to see at least the of you all are here for building robot. If you're first robot, then if you second robot, remember there are many components of it. And please participate in these competitions. We participate in all these competitions. That's why we are here and we have experience with it. And now it's your turn as undergraduates and your potential. And I see it changing competitions. And we want more from change. We want more competitors coming to participate. So I'm going to quickly share the competitions that are there out there. My in the race arena well, you don't take race movie, right? So it's just like that. Robots can go around the arena and kill each other. You can use fire, hammers, whatever else more you can use. You can kill the other robot as you go around. So it's not like this I think I showed you. I was that. Well, right? Video of how robot works. Anyone will build that one? 1%. Which students? That is. Yeah. So this is one about NIBM. That trying to burn it around. Very interesting, very expensive. But because some people connected their body down. So the very interesting and they had so maybe had 5 meters per standby. The tableau in the corner. This one. That's why I was saying what you tableau right now. So these are some of the professions that you all can take on. This is a life of a right? This is a life of profession. This is again as I said, indoor because small. I told you the circle, right? So this was a life of competition for side by side. We call it a race or something. So both robots start at the same time. The first robot goes to each base. So your competition also time this side. So this is not this side is like a battle. So first robot reaches their base. Right? This is also one of the this is also one of the robots. So that is the final. Okay. So you can see here also they have triangle V shaped. And this is why I told you this is here. Remember, if you come from here and go around, and how are you going to go straight from here to other church? This is loop, right? How are you going to enter the loop? Right? And this is why I told the circle. So most people mess up at the circle. So people enter from here, go around, and come back out of the same. How are you going to handle that? Right? So they are inverted all, and then they have, I don't think your competition has a lot of lines and a lot of lines. So when we say that, so they had got a line. So what conditions are going to use to handle that? If they are done that, right? And there are lines like this, and there are windows like this also. More RAM and something like that, right? And you serve more data here, and it's changing from here to so there are some robots that did the white transfer from here to the machine. It didn't get the change state. So these things we need to take into account. Right. More to the session, guys. My advice to you is you have to keep doing. Talk to your and for one question, you don't keep building. You want polish systems. When we recruit engineers from any university, what we do for is the hands-on experience. And robotics is a great way to have hands-on experience. Right? Because when we know that robotics, these robotic competitions, you do because you want to do out of passion. And you are here because you like it. And when we look at see, we see the same project sometimes. And it's the habit. You are forced to do it faster. But when you look at robotics competitions, we know that these people went to this competition because they are passionate about it. And we don't want people who are not passionate about it. We want people who want to be able to. Post by time. So we don't want people like that because you don't know what to learn. I'm happy to see so much people here as well because I don't know like that because you have to do robot. And also, if you keep building, you will keep learning. You will learn about microcontrollers, right? Programming, languages, C++, advanced C++, development methods, right? Power supply, how to take the power supply, different types of batteries, mechanical designs, how your robot is going to handle the friction, right? The wheel designs, so much of things would be learned and debug. So this knowledge is what we look for in the we don't want people who only knows uh, if they are looking for so we got one lady who takes the project. So one of my questions is can you explain difference between BJT and ROSCO? How you can difference between a BJT and ROSCO? What is the use case of BJT and the use case of ROSCO? And you know the meanings of ROSCO? Anything. So this question, I think nobody answered it that well. That was answered on the dot. Functions like these are two junctions, there is a fusion layer, these are the perfect. And then I asked, have you heard about the what is this? Like, have you heard about SPI and IPC? And then you know start. Like I have heard about it, I have not used it, but in the project list there is an IoT project using a GSM module. You know a GSM module is the one that is doing SPI. So they have to have used SPI. Like, so you usually make a report. What do you use? People, mosaic, so is there a difference between SPI? Like, you know what that stands for? You know how SPI works? Like, you know what mosaic means? Or MISO means? No. But you know that mosaic is supposed to quality of the eye. So you see what has happened. So from my side, the person knows that this thing was to get there, but no clue on how SPI works. No clue on master out and their pin works. No clue on the topology of SPI and topology of I2C works. You don't know. I don't know. You don't have that. But understand what you use. But how I do. Understand how SPI works. Understand that RS2 2.2, so RS485. Don't know what you they're looking for people. So learning. So with that, ladies and gentlemen, I'd like to conclude my session and leave for any questions. Anyone have any questions? So I'll be staying after this for a while. If you have any questions, feel free to reach out. Feel free to reach out as well. And again, thank you for inviting me. And I'm very happy to see each and every one of you started your robotics journey. I'm hoping to see you will do well in robotics. Keep learning. Good luck. With that, so effective on okay. If anyone wants to chat, and last but not least, that offline training process and all the time. Next, I would like to invite Ashen Fernando to set a program documentation and a small program partner. I would like to take the opportunity to invite Ms. Ashen Fernando to set the program documentation and a small program partner. And to set the program documentation, I would like to invite our workshop partner, Mr. Pvt Ltd.